Hey folks, so this is part 4 of my analysis of what fell in the UK on September the 7th, 2023, and comparing it to actual sand dune material from the Sahara and also from atmospheric dust from Iran, an area called Shiraz. So, what I said I would talk about in part 4 are the things that I found in the sample that I didn't have comparative data from the 2 peer-reviewed papers that I used as my baseline data for both the sand dune and also for atmospheric dust. So I've got nothing to compare these with. So they're just anomalies to me at this moment in time, but I wanted to share them with you. So there's a few anomalies in there that I wanted to discuss. We've got uranium. So uranium, I've got no baseline data from atmospheric dust, all from Sahara sand geochemical structure to know what normally you would have in terms of uranium. But uranium, we've got 15 parts per million in the UK fallout sample. We've got thorium at 22 parts per million. We've got selenium at 11.46 parts per million. We've got arsenic at 44.91. We've got lead at 6.26. We've got niobium at 22.64. We've got yttrium at 23.33. And we've got bismuth at 26.59. I'm not sure what that data means in the sense I don't know what to compare it with, but they are certainly questions I would ask as to why they are falling out of our atmosphere here in the UK. And how did they get there in the first place? And then we've got things like, chromium. We know chromium is natural, and I discussed it in the earlier paper, but, 454 parts per million chromium, vanadium, 273 parts per million, galenium, we've got 257 parts per million. It's just interesting. We've got rubidium, 89 parts per million. And it goes on. So this is really interesting. And I do think there's a real point to doing this analysis, and that is we really are trying to find out what is falling out of the skies all over the world at the moment. How did it get there? Is there a natural occurrence that's taking place? Is it to do with change in conditions on the planet? Or is it to do with a more sinister approach, and that is that this stuff is being put up there, which we know an awful lot of things are being aerosoled into the skies for various scientific, they call them projects, or cooling, heating it, reflecting it, deflecting it, whatever you want to do, bouncing signals. The military have been doing it for years. You bounce a signal off a cloud, so you don't need a repeater station anymore. You just find a cloud and you bounce your signal off it and get it somewhere else. So interesting. We don't have any pollutants dropping out with this rain, what I call normal pollutants, which I would expect to see, because an awful lot of what they talk to you about with chemtrails, they go, oh no, it's because of the high sulfur content. I'm sorry, I don't see it. Unless you're using lead petrol, maybe you are. Maybe you've got a lot of lead in it, because, we've got lead, but not a lot. We've got 6 ppm of lead. I'm more interested in these light elements. Why are they there? Especially when a lot of these have got some very, very interesting bimetal relationships with other metals, which I call intermetallic relationships, to do with just our health and the planet's health. So lots and lots to discuss, and this is why I'm desperate to start getting my podcast sorted out, and I really do need to just get my arse into gear and get it organised. But hopefully what I've shared with these sort of 4 quick snippets is that the data's real. What we have is stuff falling on the UK, which has got a very close signature to atmospheric dust. However, there are some elements in there and some oxide in there that are very elevated, and I'd like to have some answers to where they have come from and what are they doing there and what harm are they doing to us. So that's it.